So now we'll be solving question number 14 from previous year problems, the chapter called Forces and Laws of Motion from page 1. So this question came in 2010. Let's read the question. A block of mass m is on an inclined plane of angle theta. So there is a block here and the mass of the block is m placed on the inclined plane. The coefficient of friction between the block and the plane is mu. So the mu is given. Along with that, tan theta value is more than. As till now, you have solved a lot of problems like, and since tan theta is more than mu, and if I don't apply any force, in that case, block will be moving down. In this case, block will be moving down because tan theta value is more than, you know that. So I have to apply a force. The block is held stationary by applying a force P parallel to the plane. So I'm applying a force P parallel to the plane. The direction of the force pointing up the plane is taken to the positive. So we have taken upward direction as positive direction. Now, as P is varied, so the value of P I'm varying. So it's not constant, I'm varying the value of P. I'm varying the value of P from mg sine theta minus mu cos theta to mg sine theta plus mu cos theta. We have to make the frictional force F versus P graph. So as the variation of P is happening, corresponding to that friction will also be varying. So we have to make that graph. So when it comes to the friction, basically, friction has a little different characteristic. Friction basically will be acting as if the motion should not be happening. So friction acts in two categories. One is static friction and one is kinetic friction. Static friction is a constant value. Sorry, static friction is a variable value. It will always oppose the force which is applied and it will be equal. The maximum value of the static friction is equals to kinetic friction. If you keep applying the driving force, after a while, the friction will reach its maximum and after that, it will not be able to prevent the motion. But in this case, the body is not moving. So let's see how the things will be happening. Okay. So we have to make F by P graph. F by P graph we have to make. So if I make the FPD for the system, mg is acting downward. This angle is theta. So downward force is mg sine theta. And we have mg cos theta. We have normal. And we are applying a force P in upward direction. Now, the direction of friction. Now, since this P is a variable, this case P is variable. Now, the direction of friction will also vary. How it will vary? Please see. So what is going to happen when the P is small? So P is a driving force and mg sin theta is also driving force. So when the P is small, mg sin theta will be more than P. The net driving force will be acting downward. And in that case, friction will be acting in upward direction. As I keep increasing the value of P, net driving force downward will keep on increasing. Keep on decreasing. And when the net driving force downward will keep on decreasing, friction which I'm applying to prevent that motion will keep on decreasing as well, because motion should not be happening. So I'll go for two cases. One case is net driving down. And the second case, net driving up. It is down when mg sine theta is more than P, and this is up when the P is more than mg sine theta. Now, when the net driving force is downward direction, in that case, mg sine theta minus P will be equals to friction, and that too static friction. And when the net driving is up, in that case, P minus mg sine theta, which is the net driving force, will be equals to again F. Yes. So see in this case, so I'm increasing the P. The value of P is varying and it is increasing. So when I'm increasing the P in the first case, the static friction value will decrease because less amount of friction is required. And it will keep on decreasing and finally it will become zero. It will become zero when the mg sin theta is equals to p. At that time, friction will be zero. So throughout this variation, somewhere at one point, the friction has to be zero. Not possible, not possible, these two options, because there is no point where the friction is coming out to be zero. Then in the second case, the P will further keep increasing. If I keep increasing the P, then after a while, the friction will also keep increasing. So if you can see the behavior of friction in this case, in the beginning, as I keep increasing the P, as I keep increasing the upward force, the friction in the beginning is decreasing, becoming zero, and then it starts increasing. This is the behavior of friction. If I look at all four options, in the beginning, decreasing, and then it increases. Magnitude wise, I'm talking about, direction ultimately will also change. Now, onto this graph, up plus means upward force and minus means downward force. So in the beginning, friction was in the upward direction and it kept on decreasing. It became zero, and then the direction changed and it kept on increasing. This is the A. If you go by the B, in the beginning, it was decreasing magnitude wise, but direction was down. But that's not the case. In this case, in the beginning, section was up, decreasing, became zero, then it became down, and magnitude start increasing. So if you look at all four options, the option A is representing it nicely. It is representing, option A is representing this scenario properly. Okay. So the option A is the correct option. So this is a very nice question, because to solve this question, you need deep understanding of the friction, how it behaves and all, how it changes the direction based upon the net driving forces. Okay. Thank you.